Hello, how's everybody? Good, all right. We are going to start cyclic groups today. Um, so I'm going to start with a couple of examples here. If we Z is the set of integers, and it is a cyclic group under addition because it is generated by 1, or it is generated by -1. That is, every element of Z is clearly a multiple of 1. So 1 is a generator of Z. Similarly, every element of Z is a multiple of -1. So Z is generated by -1. Zn, integers mod n, the Zn is also a cyclic group under addition, mod n, with 1 being one of the generators, and n minus 1 is the other generator. So remember that n minus 1 is in fact the additive inverse of 1 in Zn. So 1 and n minus 1 are the generators for Zn under the operation of addition. Unlike Z, though, Zn may have more than 2 generators, depending on what n is. So, for example, if we look at Z8, Z8 has 4 generators. So Z8 has generators 1, 3, 5, and 7. So that is so every element of Z8 can be expressed as a multiple of 3. And just as well, every element of Z8 can be expressed as a multiple of 5 and 7. So these four numbers, they are all generators of Z8. Now, obviously, 7 is -1 here, and 5 is -3 here. So anytime you have a generator, its inverse is also a generator. And one thing I want you to observe here is that notice that the generators of Z8 are basically numbers in Z8 that are relatively prime to 8, the modulus 8. So 1, 3, 5, 7, these are the elements of Z8 that are relatively prime to the modulus 8. Notice that 2 is not going to be a generator. That is, every element of Z8 cannot be expressed as a multiple of 2. So let's see. So you can get, for example, 3 wouldn't be a multiple of 2 in Z8. So 2 cannot generate all the elements in Z8. Now let's look at a multiplicative example. So if I look at Z10 star, recall that Z10 star is the set of integers between 1 and 10 that are relatively prime to 10. So Z10 star has 4 elements: 1, 3, 7, and 9. So those are the 4 elements of Z10 star. And Z10 star is cyclic because it has 2 generators, 3 and 7. Now notice that 3 and 7, 7 is the multiplicative inverse of 3 in this group, in this multiplicative group. So 7 times 3 is 21, which is modulo 10 is 1. So 3 and 7 are, 7 is the inverse of 3. If, like I said, if you have a generator, its inverse is also a generator. Now you can check that if I take, now I'm not going to take multiples of the generator because now it's a multiplication. So you take the powers of 3 here. So notice that if I look at 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, and 3 cubed 27 more 10 is 7. So notice that powers of 3 cover all the elements of Z10 star. So 3 is a generator, and you can check the same for 7. Now, just so that you don't think that any Zn star, so Zn is cyclic under addition for any n, but Zn star may or may not be cyclic. So here Z10 star is cyclic, however, Z8 star isn't cyclic. Z8 star again is the set of integers between 1 and 8 that are relatively prime to 8. And Z8 star is not cyclic because it doesn't have a generator. So for example, 3 doesn't generate Z8 star. So to see that, notice that 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 1 again. So notice that 3 squared gives you 1 back, and beyond that, if you look at 3 cubed, you're going to get 3 again, and then beyond that, you're going to keep getting 1 and 3. So 3 is not a generator. Similarly, 5 isn't a generator, 7 isn't a generator, and obviously 1 isn't a generator. So 1, 3, 5, 7, those are the 4 elements of Z8 star, and none of them are generators of Z8 star. So Z8 star is not cyclic. Okay, so I am going to stop this video here, and I will see you in the next one.